missing a very
Chase!
important day
Hi,
of
Chase!
school.
What's goody, brother?
All right, here we go.
It's your favorite person.
He's going to be like, who?
Jason.
Let's do number 5 together because I need to edit it. It printed weird. I want you to cross this off. Shh. Guys, it's hard to listen to the video if there's any crosstalk. Okay, so let's cross off the numerator and put in 5x squared minus 2x minus 3. Okay? The top was not factorable. The instructions here say that I need to find the x-intercepts, the y-intercepts, the horizontal asymptotes, and the vertical asymptotes. Let's go ahead and do so. Now, it's not entirely sure what this looks like, so what I'm going to do is factor the numerator, factor the denominator, and see where I end up. I factor weird. Everyone doesn't know how I factor. You just factor the way you want. It's all fine. It's to train you to learn how to do GCFs. So it's just how I train it to learn how to pick out big GCFs. But if you get 5x plus 3 times x minus 1, you're good. Whatever way you want. I know you all have your different methods depending on who your teachers were. Okay. Let me know when you end up here. Give me thumbs. We're factored. All right, cool. So how do I find the x-intercepts? The x-intercepts are when I take the numerator and I set it equal to 0, okay? So now, just not yet, because you want to make sure you get at all the information, and then we'll get there as we work through. But you're right. So then I have x equals negative 3/5, x equals 1. So my two x-intercepts will be negative 3/5 and 1, 0. Okay, my y-intercept is going to be when I take a 0 and plug it in everywhere I see an x. So now I would have 3 times negative 1, which would give me negative 3. This would be plus 1 minus 1, negative 1, reduces to 3, 0, 3. Horizontal asymptote. Ooh, let's go back to before we factored it. What was the highest exponent represented in the numerator? X squared. What was the highest exponent represented in the denominator? X squared. So it'll be 5 over 1. My horizontal asymptote is y equals 5. Let's review those rules really fast again, okay? So when the degree in the numerator, let's call him x to the n, is greater than the degree in the denominator, let's call him x to the m, the horizontal asymptote does not exist. We have a much larger quantity being divided by a smaller quantity. It would just head out towards the infinities. We would say no horizontal asymptote. When the degree in the numerator is equal to the degree in the denominator, we have a horizontal asymptote at whatever the ratio of the coefficients are. Whenever I have a higher degree in the denominator than I do in the numerator, that was weird the way I said it, but do you see what I mean? You have like a bigger exponent in the bottom. Yeah, I guess. I don't know why, but I just made it up. I don't know. So then you have y equals 0. That would be the horizontal asymptote, okay? Okay. Sound good? Little review? Okay. Vertical asymptotes. Well, let's see. He cancels. What does that look like on the graph? What does that look like on the graph when two factors cancel?
A hole.
A hole. Very good. There is a hole at x equals 1. And then what happens with this bad boy, this little factor left over in the denominator? This is the vertical asymptote at x equals negative 1. Okay?
I thought it's supposed to be the opposite.
What do you mean?
I thought it's supposed to be positive.
No, because you're setting that factor equal to 0, solving for x. That's why inside the parentheses, the sign is the opposite of what you think. If you find the value that would make that whole thing equal to 0, it's the opposite.
Okay.
Yeah?
So just for class, so
There's stuff that cancels out.
Yep.
where'd you bring it?
So like the
Where'd I get the -3 from? Where do you see, where is there a -3? Wait, hold on, what do you mean?
Like the bottom left, where you wrote -3 over -0.
Oh, that's the y-intercept. I plugged in a 0
Oh,
to factored form and just did it in my head because that's usually the fastest way. Yeah? And then it came out to be that guy. All right, next station. Come with me to the Gnomnasium. It's kind of like the same thing, but it's less work. Cross this off. I don't have a gnome hat, and for that I'm disappointed in myself. But we're finding the x coordinate of the holes, then horizontal asymptotes, then vertical asymptotes. Let's go. Let's do number 1 together. Okay. Number 1, will there be a hole?
Yes.
There is a canceled common factor at x equals 5. There is a hole at x equals 5. Is there a horizontal asymptote?
You crossed out the wrong thing on the bottom.
What? Oh, yeah, here you go. All right. So now, I have a feeling because of just doing problems many times that when I expand these guys, I'm going to end up getting a polynomial with a leading coefficient of x squared. But just double check, right? Make sure. So I would get 2x squared minus 10x. What's up? Plus
it
x.
would be the top one. It would be the top biggest coefficient divided by the bottom biggest coefficient. So like say for example, like the bottom part factor it's like a 10. It wouldn't have anything to do with the solvation of the horizontal asymptote.
Whoa. Hold on a second. I'm shook by salvation. Hold on. Give me a moment.
I don't need to.
Hold on, I'm saved. Wait. Okay. So, what are you asking me about?
So for example, it would be to find the horizontal asymptote, it would be 2 divided by 1.
Yes.
Okay.
Yep. Is that what you were asking me about?
Steve, you want to take both?
All right. What about the vertical asymptote?
X equals 2.
X equals 2. Good job.
Yes, queen.
Because there is one leftover factor in the denominator. So if I set him equal to 0, I'm going to find that x value that it can't be because we can't divide by 0. I think we need to make a poster that says salvation. Are you solved? Like, are you saved? Yes. The Salvation Army. We need t-shirts that say Salvation Army. That's us. We are the Salvation Army.
Almost got bumped in the head.
All right, guys, let's go to number 3. Meet me at stop 3, Monster Mound. Let's go. What happened to St. John?
Yeah. He's a
Funeral.
I don't know. Oh, yeah, that makes sense. Hold on, this is tickling my face. Okay. Which one should we do? Which one should we do?
We should do all of them.
Yeah.
No, I don't
Number
want to
3.
waste your time.
Number 3.
Oh, do you guys remember how to factor stuff like number 3? We can do that. These are easy. These are going to be quadratic. You're going to find your x-intercepts by factoring, and then you're going to test your solutions on a number line. Let's try this guy. Let's try number 3. Whenever you have x cubed, and then there's polynomials for each power going down, each descending power, you can just do factor by grouping. You guys remember this?
Yes.
All right, so you got x squared out front for the first factor. These become, over here, they are like the GCF of this guy. You want to make sure that these match, and that means that you've done it correctly. Am I done?
No.
How do you know I'm not done?
The x squared. Oh.
Wait a second. What does this become?
Squared.
Just a little repeated root there, yeah.
Oh.
Okay, so that's just gonna affect like signs of stuff. That's kind of it. What are the two? What are the two numbers that are still going on your number line? Yeah, very good. Yeah. What kind of circles am I gonna put? I'm gonna fill them in. This is the inequality. Stop doing that. All right, let's pick something in the middle, 0. Let's pick something above, 3. Let's pick something below, -3. And then let's test them into our factored form over here. All right, I got -3 plus 2 is going to give me a negative. And then -3 minus 2 is going to give me a negative. But then he's squared, so he's going to be positive. So then what am I putting for this interval right down here? Woo! Okay, then let's test this guy, 0, so it would be positive times a negative, but then he's squared, so he's positive.
So it's gonna go.
Number 3, it will be positive, a positive, so positive. Okay. So wait a second, what is the criteria that we want?
Must be less than 0.
Less than 0? Okay, so we're going to shade down. Sounds good. Our range of solutions would be... Oh, are we feeling all right?
Absolutely.
Is plague harming our Salvation Army?
Yes.
Oh, wait a second. I've forgotten a solution. Who can find where I've forgotten a solution?
2.
I want where x is, I want where x is less than or equal to 0. So we got the whole range of solutions, but then he's also filled in at what little point on the number line? Okay, so let's go ahead and pop him in there. Yeah.
Oh.
Yeah.
Yes.
It's only at 2, so we would write it like that.
Only 2.
That's cool.
Only 2.
It is cool.
Only 2.
You know what's really cool? Those
Come with me to the next stop.
Wait, can you go back?
Yes.
2 seconds.
I really like those.
Very few. Yeah, those curls.
Wait, why does it need to? Just because there's the...
There's also filled in circle right there because he's another spot where it's 0. So everything was good because it was less than 0 to the left, and then or equal to gives me that other little guy over there. Hi. Yeah, sure. She has to put her shoes on. Hold on.
We have to do all of these just today.
You need to represent the Salvation Army appropriately and put your shoes on.
I have to do all of these just today.
They really go, like, usually this takes one whole regular class. So at home, what's it going to take you, like, 40 minutes? You know. We'll finish up the ones we didn't finish in class. Okay, let's look at this guy. This is going to be what? State the domain. State the domain. Which one do you guys want to do? The last one, I guess, is the worst.
Oh my god.
Okay, so immediately, what is my initial domain restriction?
Yes. 5.
Okay, so that's one of them. Now let's figure out the other part. I'm going to go underneath the square root symbol, take the argument, and set up my inequality. I need him to be what?
Equal.
Not equal to 0. We want everything where he's greater than. Can he be 0?
Yeah, you can.
Yeah.
Everything is greater than
Absolutely.
-1.
Shocking.
Huh. What do I do with this information here?
Die.
You just what? No, not die. We could,
Why would you say that?
Jason. Because I don't know what
yeah, let's put it in our little form here, right? X is an element of all reals such that X is greater than or equal to -4. However, X cannot equal 5. Right? It's just like, okay, I know the math. I gotta think, and then I'm good. I never think. Okay.
Don't even
Let's do, are we in order? Yes, stop 5. I would like to direct your attention to the numbering on this page. The first question has no number. Question 2 is 4B. And then the last problem has no number. Let's do 4B. What do you think? Okay. Let's review. Let's review how to do this. It says, using your knowledge of inverses, find the range of y equals 2x minus 1 over x plus 4. I know that I do not have any idea what this thing looks like, so I cannot use my knowledge of functions to figure out what the range would be. If it was the square root of x plus 1, I know what that guy looks like. I could just say the range. But I need to find the inverse algebraically. Good job. I'm going to switch x and y, solve for y again, generate the inverse function, and then I'm going to see if there are any domain restrictions on the inverse function. He becomes my range of the original. Let's do it. I wish I could like tape all the faces of the people walking by.
I'm not trying to. You can. My mouth is made out of titanium. I can.
Guys, work through this on your paper because I can't tell you how many times I went to go look at a test and the people get stuck right here.
I get stuck right there.
Think in engineering. This is your single point failure right here. This is where everybody gets lost.
Sit on X.
I got this.
You're going to sort, get all the y's over together.
Wait, I just put an X back in. I have English after this. I'm really
All right, now I'm going to take out a y.
Yes.
My dog just comes running in. All right, so we got our inverse, and then this is all relying on the fact that we have the domain of the original. We have the range of the original. We have the inverse of, what is that noise? We have the inverse of the original. Oh, sorry, hello. This is the domain of the original, of the inverse. I can't concentrate. What is that noise? Do you hear that? No, I think it's Miranda. Is that you? Oh my gosh. It's making my teeth hurt.
What?
You know that feeling like when you touch like a towel and it's really dry and it makes your teeth hurt?
No.
Or like
Different.
Grace just goes,
I'm pretty sure that's like the next girl's head.
ah! Oh, it drives me nuts. Okay. Ah, okay. So now let's look at this guy. Oh, what did I do wrong? How many people got a different version of this, but wonder if it's the same? Hold that thought. If you ever do these, right, rational functions, you're going to end up with a different expression depending on the order in which you move stuff over or divided. So the way you can test and see if your answer is equivalent to mine on the answer key, say, I don't know, you can graph it and then see if your function lays right on top of the one that's on the paper. So if I got... what is this? It's the government. Okay, so you can type in the one I had, 4x plus 1 over 2 minus x. And then who has one that I can test? Yes, just for the purposes of this example, give me yours. Hold on, I can't hear someone who is giving me an answer. What is it, negative 4x? Uh-huh.
Over x minus 2.
Oh. Yay, they're the same. Okay, so if it lays right on top of the other graph, they're equivalent. The way that happens is like I could factor negative 1 out of his and then like cancel it. Yeah? Okay. It looks good. I'm excited. Okay, so in the original, right, I had to exclude x cannot equal negative 4. In the range of the original, if I figure out the domain of the inverse, I can have that blob filled in and just take the y value in there, okay? So what is my domain restriction in the new inverse here? X cannot equal 2. So it would be x cannot equal, nope, because 2 minus what gives me 0?
No, but I'm saying it's a negative 2 minus x. So if you want to get 2 the second part.
You said it equal to 0, right? Yeah. So then, we need to give our answer as a range. So we would just say y is an element of all real such that y cannot equal 2.
Is there going to be a no calculator part on our test?
I don't remember.
Wait, what?
I hope not.
I'll let you know though.
Hold up. Wouldn't our wouldn't the range, wouldn't the domain of our previous be the range of our next one?
One of the domain of the inverse is the range of the original, right? So
Yes.
I don't even know what page
Then
we're on.
shouldn't our range be y not equal -4?
No, because that's the domain of the original. Right? Think.
Is it the same thing as isn't the range of the
Stop
the same
touching
thing
me,
as the
please.
domain of
Stop
the
touching me, Steve.
No, follow the inputs, right?
Literally just touch my arm.
X
I'm trying
goes
to
into
learn.
the output. So you have the domain of x, or the domain of f of x sees all the x's. You have the range of f of x sees all the y's. When I find the inverse, right, that's this guy down here, you're basically just switching
We're
these
finding
two
the
blocks.
range of the original.
Yes.
Okay, not the range of the original.
No. You gotta find the range of the original, and you do that by finding the domain of the original. Okay. You guys got that? That's sneaky and
Yeah.
Sneaky peeky like.
oh yes, a sneaky peek.
Let's go bathroom.
All right, this looks very much so like the quiz that I gave you, but with different numbers. So I'm not going to go over one from here, but I do want you to take a look at this last little problem right here on Mandrake Mudhole. Do not try him until the very end. He is the final boss. He is, however, someone who you should definitely try before the test.
So is he gonna be?
Can you see me? Can you see, I'll never give you a question that you saw before on the test. But there's something that's like him on the test.
Bro,
Our test is on what? Wednesday?
Yes. Yes, yes. And then is this it? Is this the end? This is the end. Okay, do you like my little, I typed this into Microsoft Copilot. He's AI generated. He's cute, right? All right, this is, his name is Salvation Army. Okay, so we've got the final stop here. This is where you have to have such a deep understanding of all the different parts that make up a function that you are able to generate your own with specific characteristics. Okay, so I feel like, I don't know. You guys want to go through a few together? Let's see. I feel like E is probably the trickiest. You want to talk about E?
Yeah.
Okay.
Yes.
So the domain is X is an element of all reals. Tell me, what does that look like on the graph? X is an element of all reals.
What?
X is an element of all reals. What does that look like on the graph?
like negatively infinity?
Yeah. Are there any vertical asymptotes?
No.
I go for
Yeah,
infinity.
there can be.
Okay. But there's no vertical asymptotes. This is a rational function.
I don't think I'm gonna get Pedro either. What's his name? Pedro? What's the guy's name? Where?
What is the only exception to the rule? You have a rational function, but there's no X or no vertical asymptote. What is that going to look like? You have a quadratic in the denominator
Well, you
that's
just shade
never
everything
equal
in.
to 0. So, what?
Will you just shade everything in without vertical asymptote?
If you wanted to test everything on the number line, you could. But I'm envisioning like what this would look like. If you have a denominator and there's something in there that never equals 0, couldn't you have a quadratic that never crosses the x-axis? Like he's been shifted up,
Yeah.
right? So you would have like, I don't know, like x squared
Yes, someone take it.
Oh.
plus what? Something like that? Yeah? Would that work?
Yeah.
Okay. And then there is no x-intercept.
That means it's negative, right? So-
There's no x-intercept. This whole guy needs to be what? Vertically translated up, right? Like above. Or I mean, you could do it down too if you want, but no, because then he's going
Is there,
to, yeah.
is there two horizontal asymptotes?
Translate it up.
Is there two horizontal asymptotes?
No,
Never mind.
no. So if we have like, maybe something like this at the end. So he gets translated up, so there's no x-intercept. There's a horizontal asymptote of y equals 3. So if I've got an x squared in the denominator, what needs to go up in the numerator?
Oh, 3.
Good. We're getting it. We're getting it.
Who is it?
And then you need a y-intercept at 0, 4. Oh, I didn't see that. What should I do here?
Oh, finagle.
These have an equal degree in the numerator and the denominator. So there would be a horizontal asymptote at y equals 3, right?
Yeah.
So if this guy needs to have a y-intercept at 4, what should I be doing here?
Put it up forward. Wait, no.
I don't know. Let's take a look.
You know what I'm saying?
I think it's going to have to do with the vertical translation. What do you guys think?
Yeah, you gotta
I
put
think
it
so
up
too.
one.
Let's graph this guy and see what he's going to. Oh, actually, I'm going
You
to
just
fill
gotta
up a new
put
one.
4 instead of
Let's see. Get out your calculator because you're going to need to mess around with one of these on the test. So let's practice messing around with these right now, okay? So I've got 3x squared. Oops. 3x squared. And then I've got x squared plus 1. And then I've got
Actually,
plus
that was right.
3. Oh, okay. So he has no
gotta hit it with a +4.
x-intercept. His domain is all reals. There's a horizontal asymptote at y equals 3. What is the y-intercept though? 1, 2, 3. So what should we change to over here?
You just change it to +4.
Ah. Oops. Now are we good? Yeah. Okay, so do you see how you can you got most of it and then you're like, I need one more piece. What should I change here? Yeah? Okay.
Because then
So let's change him to 4. And this would be an example of one. Cool.
How did we end up not getting hats?
Halves. Hats. Oh, here, go ahead. Yeah. The first